Hello students, in today's session of NCERT Chapter 9, Optics and Optical Instruments, further very basics will be clear through illustrations taken from NCERT back exercise. Topics to be discussed are real depth, apparent depth, laws of refraction, total interval refraction, and principle of reversibility. In earlier session, we have gone through reflection from spherical surfaces, which you can review on Sethi Swift Learn YouTube channel. Now, let's start with the question and concept. Question is: a tank is filled with water to a height of 12.5 centimeter. The upper depth of a needle lying at the bottom of the tank is measured by microscope to be 9.4 centimeter. What is the refractive index of water? One is to find refractive index of the water. If the water is replaced by liquid refractive index 1.63 up to the same height, by what distance should the microscope have to move to focus the needle again? In this session, we are going to discuss real depth and apparent depth. Right? Now, in this concept, applicable and solution. Apparent depth and normal shift. The depth of an object immersed in water appears to be lesser than its actual depth. This happens due to the refraction of the light. The apparent depth is less than the real depth. Means here is the observer, here is the object. Object is in denser medium, observer is in the real medium. When ray of light goes from denser to rare, it moves away from the normal. This is the normal. This is the normal. If we extend it further, this is the point. And a ray of light incident normally retraces the same path. So this is O dash. Point of intersection of these two rays are O dash. O dash is the image formation. Point of image, right? Then O dash is normal shift. That is real depth minus apparent depth. Real depth minus apparent depth. That is real depth, apparent depth. That real depth is AO and apparent depth is AO dash. Depth means we have to measure the distances from top end. Right? This is the and mu equal to होता है real depth upon apparent depth. Real depth upon apparent depth. This is derived. Now, here ray of light is traveling from denser medium to radium. This I have stated here. Now, consider beaker filled with invisible transparent liquid of refractive indexes mu1, mu2, mu3 and real depths d1, d2, d3. Then apparent depth of the grain is given by mu1 over d1 over mu1 plus d2 over mu2 plus d3 over mu3. Using this concept, real upon mu, so all will be added. Right? Now, let's start with the question. Now, question is, we have gone through the question. The tank is filled with water. Suppose this is the water to a height of, this is the 12.5 centimeter. And object, this is object and this is order. This is real apparent depth. This is given to 9.4 centimeter. Therefore, the refractive index of water will be real depth upon apparent depth. Real depth, this is 12.5 centimeter upon 9.4, that comes out to 1.33. Mu W comes out to be 1.33. This is refractive index of water with respect to air, right? In the part 2, this is case 1, case 2, case 2. Refractive index, water is replaced by refractive index. Water is replaced by liquid refractor 1.63 by liquid of Ri 1.63. Therefore, apparent depth will be real depth upon mu. Real depth of 12.5 centimeter, mu is 1.63. On simplification, this comes out to be 7.69. Means in the two cases, first is audacious with water. This is 9.4 centimeter. And in this case, this comes out to be O is O double dash is with liquid, with water. This comes out to 7.69. O dash is to 7.69. Means to shift microscope upward, that is equal to 11.9.4 minus 7.63. That comes out to be 1.73 centimeter. Means microscope is shifted to away from the liquid, that is 1.73 centimeter, to focus the needle again. Right? Now, next question. Concept is on laws of refraction. Before start of the question, we will clear the concepts. Laws of refraction. What is laws of refraction? The incident ray, the refracted ray, and normal to the refracting surface or interface at the point of incidence all lie in the same plane. This is the normal. This is the incident. This is the refracted. This is the refracted. Change of medium is that is the reflection. If same medium after reflection, that is the reflection. One is Snell's law. The ratio of sine of angle of incidence to the sine angle of refraction is constant for two given media. This constant is denoted by 1 mu 2. 1 mu 2 means mu 2 over mu 1. That is refractive index of medium 2 with respect to medium 1. And 1 mu 2 can be extended further equal to V1 over V2, velocity medium, that is equal to lambda 1 over lambda 2, and F, that is frequency constant. Whether reflection frequency remain constant, that is the Snell's law. One is from, two is to. Incident ray is this medium, refracted ray is in this medium. That is the refractive index of medium 2 with respect to medium 1. This is known as Snell's law. Now start with the question. Question is, following figures A and B show refraction of ray in air incident at 60 degree with the normal to glass air and water air interface. This is the glass air and water air interface. Predict the angle of refraction. We have to find this angle. When angle of incidence is 45 degrees, is normal to the water. Figure C. In this we have to find. This is given. We have to find out. What is Snell's law? Snell's law is 1 mu 2 over mu 1 equal to V1 over V2 equal to lambda 1 over lambda 2 and F equal to constant. That is frequency. These are the wavelength, these are the velocities, right? These are refracted index with respect to air. Now in this case, figure 1, figure ऐसे ये from होता है, ये 2 होता है. Now in this case, from air to glass, figure A is from air to glass. That is A mu G. That is sin I upon sin R. That is equal to sin I upon sin R. That is sin I upon sin R. That is sin 60 degree upon sin 35 degree. This comes out to be root 3 by 2 upon 0.57. On simplification, this comes out to be 1.51. The refractive index of this 1.51. From figure B, this is air to water. From air to water. Be very, very careful regarding from to. From to is the only concept. Then A mu W equal to sin I 60 degree 47. Sin 60 degree, sin 47 degree. On simplification, this comes out to be 1.19 after substituting the values. Right? Calculation आप लोग कीजिए, ठीक है? And then we have to find the angle of refraction. In figure C, from is water to glass, from water to glass. That is W mu G. W mu G means sin I upon sin R, mu 2 over mu, that is A mu G upon A mu W. So sin R comes out to be sin I into A mu W upon A mu G. Sin I is 45. Sin 45. A mu W is 1.19 and water is 1.5 A mu W. 1.19 divided by 1.51. On simplification, this comes out to be 0.56. 0.56. So R comes out to sine of inverse 0.56, or you can say 34.06 degree. This is the answer 1. Now, in this case, application of Snell's law is there. Snell's law is applicable when change of medium is there. From to. From is the medium in which ray is incident. To in which after refraction rays passes through. Right? Now in this case, this is air water. This is 67 degree. It is bending towards normal because this is the denser medium. In this case, there is incident water. It is bending towards right. In this case, water glass. We have clear all the concepts. Now, next question. Before start of the next question, I will request that these concept killing videos, which are very useful for 11th standard, 12th standard, CBSE board, state boards, JEE, NEET, CUET, and other entrance examinations, which you can review on Sethi Swift Learn. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल Sethi Swift Learn सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the question. Concept will be on total internal reflection. Concept will be clear to this question. Question is, a small ball is placed at the bottom of tank containing water to a depth of 80 centimeter. What is the area of the surface of water through which light from bulb can merge out? The refractive index of water is given 1.33 and consideration is bulb to be considered as a point source. Before start of the question, concept will be clear on TIR, that is total internal refraction. What is total internal refraction? When a ray of light traveling from denser medium to rarer medium, this is a denser medium, this is the rare medium, is incident at the interface of two media at an angle greater than the critical angle of the two means. Angle of incidence should be greater than angle of critical. The ray is totally reflected back to the denser medium. Means ray incident it refracted goes on increasing the angle of incidence, angle of refraction is increasing as mu equal to 1 mu 2 equal to sin I upon sin R. As I increases, R also increases for same pair of media. Same pair of media means, and sin increases with angle. So it goes on increasing the angle of incidence, a stage will reach when this angle will become 90 degree. R will become 90 degree. That the angle corresponding to the angle of incidence at which angle of refraction is 90 degree, that angle of incidence is known as the critical angle. Now, when angle of incidence increases the critical angle, this ray is reflected back, does not go to the another medium, that is the red medium. This phenomenon is known as a total internal reflection. Now, what is critical angle? For a pair of given media in contact can be defined as the angle of incidence in denser medium, for which angle of refraction in the red medium is 90 degrees. This I have explained here. The value of critical angle depends on the nature of two media in contact. Graphically, figure wise, this is the denser medium, this is the rare medium. The angle of incidence IC corresponding to which this is angle 90 degree. In this case, I will be equal to IC, then R equal to 90 degree. Condition of total interrefractions. The ray incident of the interface two media should travel in the denser medium. That means ray of light pass from denser to rare. Angle of incidence should be greater than the critical angle for 2 meter. These are the necessary conditions. Now let's start with the question. Question is, small ball is placed at the bottom of tank containing water to depth of 80 centimeter. $80 centimeter तक water. 80 centimeter. This is the water. Now, ball is placed here. O, point source. You have to find the area. What is the area of the surface of water through which light from ball can merge out? This is A, this is B, this is D, this is O. If we made this, we made this. This angle should be equal to C. TIR is applicable when I equal to C, I greater than C and denser to rare. So we have to find the maximum area. So apply Snell's law. What is Snell's law? From water to air. Sin C upon sin 90. That is sin C upon 1. So this comes out to be 1 upon 1.33. That is sin C equal to 1. Therefore, sin C comes out to be 1 upon 1.33. On simplification, this comes out to be, C comes out to be 48.6 degree. 48.6 degree. Now, we have to find AD equal to BD equal to R, radius of disk. Radius of disk to be placed over, after which ray of light will merge out. Now, to find R, using triangle OAD, in triangle OAD, tan C will be equal to AD upon OD. AD upon OD. That is, AD is R upon OD. That is 80. 80. R comes out to be, R will come out to be, R 10C, 10, 48.6 into 80. R comes out to be, on simplification, 0.9 something. Therefore, area will be equal to pi r square. Put the values and find the answer. Answer is 2.5, 2.51 centimeter square. 2.51 centimeter square. This is the answer. Right? Next question. Question is, given that 1 mu 2 equal to 4 by 3, 2 mu 3 equal to 3 by 2, we have to find 1 mu 3. Concept applicable. Medium 1, medium 2, medium 3, medium 1. Means initially first and last medium is same. Then if we start from here, the refracted ray will be parallel to incident ray. Lateral shift will be there. If we start it from here, it will retraces the same path. That is the principle of reversibility, right? In this case, 1 mu 2 into 2 mu 3 into 3 mu 1 will be equal to 1. From 2, that is equal to 1. Mu 2 over mu 1, mu 3 over mu 2, mu 1 over mu 3, that is equal to 1. We have to given 1 mu 2. This is given to you. This is given to you. We have to find the reverse of this. 1 mu 3 into 3 mu 1 will be equal to 1. So, right. So, substituting values in 1. 1 mu 2, 4 by 3, 3 by 2. 4 by 3, 3 by 2 into 3 mu 1. 3 mu 1, that is equal to 1. On simplification, this comes out to 2. 3 mu 1 equal to 1 by 2. As according to principle of reversibility, 3 mu 1 into 1 mu 3 equal to 1. Therefore, we have to find 1 mu 3. 1 mu 3 equal to 1 over 3 mu 1. That comes out to 1 upon 1 by 2, that is 2. 1 mu 3 comes out to 2. This is the answer. Right? Now, I would like to request, if you are new to my YouTube channel, Sethi Swift Learn, Sethi, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.